Alrighty, so we're going to talk about we're going to talk about a lot of different kinds of transformations today. The first transformation we're going to talk about is a translation, okay? And so our essential question that we want to be able to answer is, how do you draw the image of a figure under a translation? Okay, so quick little refresher on transformations. Remember that a transformation takes a figure okay, it undergoes some sort of transformation, and we arrive at what we call the image. Okay? So we start with what we have as the original figure, a transformation occurs, and we get its image. Okay? The original figure sometimes is confusingly called the pre-image. Okay? I think it's super confusing to call it the pre-image, but that's the way it is. So it's either the original or the pre-image, and then the image. All right. Now, when we talked in the warm-up, right, Aubrey was able to discern that when we translate, the size and shape of the figure does not change. Is that true for every transformation? Or in other words, are there transformations where the size and shape of your original figure will change? Yeah, absolutely. Okay, we have all sorts of different kinds of transformations that could occur, but this is just. But there are also transformations that keep the size and shape. Okay, so again, we'll talk more about that too. All right, so let's kind of take a look then at translations. Okay, we're not going to actually do this translation. We're just going to kind of walk through it here because it's kind of silly to do it when they just have it all done out for us right here. So a translation slides all points of a figure the same distance in the same direction. Okay, so that's crucial. Same distance, same direction there. Okay, and that's what a translation does. Okay, you can use tracing paper to model translating a triangle. We're not going to do that though. Our tracing paper, by the way, is like the patty paper, but anyway. Okay, so first, again, we're going to have our triangle ABC, and then we're going to draw a line segment XY. And we're going to use this line segment XY to translate ABC. Okay? You'll see that XY kind of has both a length to it, right? But it also kind of has like a direction, right? It's kind of going up a little bit and right a little bit. Well, right more, right? Right and then up a little bit. And so what we're going to do then is mimic this XY segment, right, here on point A. So you can see there's XY, and if you were to move that right up here, you'd see it would match perfectly from A to A prime. Of course, right? A prime, right, that's the name of A when it's been transformed, right? Okay, so there it is, moving that distance and the same direction as that segment XY. And then you do the same thing to get B to B prime and then to move C to C prime. You can't really see the prime there. I'll kind of make it more obvious. Okay? Those all, well, I guess you'll see right here. Those all result in our translated figure here, moving this specific length and this direction here as well. Okay? Translation. And as Aubrey correctly identified here, triangle ABC, right, is the same size and shape as triangle A prime, B prime, C prime, the image there. Okay, pretty simple, straightforward stuff. All right, turn the page there. So it asks us here to measure the distances A prime, B prime, and C prime, and finally XY, and then describe how A prime, B prime, C prime are going to compare to the length of XY. Well, how will those lengths compare? So again, how will the length from B to B prime, the length from A to A prime, and the length from C to C prime, how will they compare to that length XY? What's going to be true? The same, exactly right, because didn't we use that XY to measure from B to B prime, A to A prime, C to C prime? So yeah, they will be the same. Okay, they will be the same. Okay. Next question here. Let's see if I can scoot that in there. Okay. Are BB prime, AA prime, and CC prime those segments? Okay. Are they parallel, perpendicular, or neither? Well, let's look back there. What does it look like? The segment BB prime, the segment AA prime, the segment CC prime. Does it look like they are parallel, perpendicular, or neither? What do we think? If you were to extend those lines, what would you say? Emmanuel?
Neither.
You say they're neither, so you think that if I were to extend...
Oh, wait. That would be parallel.
Okay, so you're saying now they're parallel. So you're saying that if I were to extend BB prime, extend AA prime, extend CC prime, they would never intersect. Right? That means they're parallel. Yeah, that's right. Exactly right. They're going to be parallel because, again, they're all going the same direction there from X to Y. Okay? So, parallel. Now, how might we be able to check to see that that's a reasonable solution? Any ideas? How might we check that? How might we be able to check to see if they would be, in fact, parallel? Or what maybe it could be a way we could just kind of convince ourselves they're going to be parallel there. Any ideas? No, Lydia? Okay, so and if that was the case, we would need to be in the coordinate plane, but absolutely, we could find the slope between those points and then go from there. All right, excellent idea. So we just talked about parallel lines having the same slope. Okay, that I think is going to be our best bet right there, Lydia. I can't think of much else we could do there. So yeah. Okay, we could talk about, if I go back here, we could talk about saying, okay, well, like BB prime, if I extend that, and AA prime here, okay, we could talk about like, oh, thank you. Did anyone else need the marker for their books? All right, we'll get you guys here. There you go. Okay. We could talk about, like I said, extending those and then seeing, aha, here's a transversal. So this angle right here, A, would correspond to this angle right here. Okay, and then likewise, if we expect, AB to be parallel to A prime, B prime, those should be congruent as well. And so it looks like we have like a bunch of like congruent angles in there and stuff too. So you could potentially use like the transversals and parallel line stuff as well. But again, I like Olivia's answer there. Probably using the slopes would be the best idea. All right. So how does the angle BAC relate to the angle B prime, A prime, C prime? So we go back here. How does, and I'll use this one since I've kind of drawn all over that one. How does the angle BAC relate to the angle B prime, A prime, C prime? What do you guys say here, Jenny? They're the same. Exactly right. They're the same. And of course, in geometry, we're going to use the word congruent, right? They are congruent. How might you explain that, Jenny? What kind of clued you into the fact that you thought they were going to be equal? Exactly. Translations, thank you, do not change size or shape. Okay? By the way, transformations that maintain size and shape are called rigid motion transformations. Okay, rigid motion transformations. So we can refer to translation as a kind of rigid motion transformation. Okay? A translation is a rigid motion transformation. It does not change the size or the shape. All right? Questions on anything up to that point? All right, so let's actually do some translations here. There's a couple different ways to do translations. So one way is to translate figures using vectors. Vectors, we've seen those, right? They showed up in our GeoGebra, okay? If you pursue like engineering or pre-engineering here at the high school, you will work with vectors. Okay, vectors look like rays, but they're not. Okay, so let me talk about this here. So a vector is a quantity that has both direction and magnitude. Okay, so here is a visual representation of a vector. Okay, this dot here, E, is called the initial point of the vector. It's the starting point, right? Which is like a ray. But then you'll notice here, this point right here where the arrow points to, it's a terminal point. So in other words, this vector does not go on forever, infinitely, in one direction like a ray does. The vector is essentially just showing like the direction and magnitude, right? It's saying E to F, like that, E to F, and then stops. It does not go on forever. Okay? So you can see why using a vector in GeoGebra was a wrong thing to do. Vectors are finite, rays are infinite. They go on forever. Okay? Here's some different ways you can name a vector. You can name the vector shown by naming it with EF, and you'll notice it looks like a ray, but it's missing one of the tails for its arrow. Okay, you see that subtle difference? Okay, so that is a ray. That is a vector. Okay, notice the difference there. No, I'm sorry, there you go. Notice that difference. Or you can also, of course, name the vector with a single letter, like a cursive letter. And there, again, the vector thing. Okay? So, little notation stuff. Moving on. Okay, it is convenient to describe translations using vectors. A translation is a transformation along a vector such that the segment joining a point and its image has the same length as the vector and is parallel to the vector. Okay, so in other words, here's vector v. Okay, this segment that joins the pre-image and the image, okay, is the same length as that vector, and it's parallel to the vector too, right? B to B prime is parallel to this vector v, and it's the same length as that vector v. Okay? So, and we can use some of this information here to help us to draw translations. Parallel lines are always the same distance apart and never intersect, and parallel lines have the same slope. So we'll be able to use that to help us translate the vector here. Okay? So, in letter A, we're asked to draw the image of triangle ABC after a translation using vector v here. So here is vector v. Okay? We can see that the vector is going right 4 and then up 2. Okay. To then use that over here, we're going to do the same exact thing for each one of our vertices of our triangle. So for example, point A. To get A prime, how should I move from point A? Right 4, 1, 2, 3, 4, and up 1, 2. And there it is. What should I name this new point? Yes, A prime, because it's a transformation of point A. Right? Okay, great. How should I move point B? Same way, right? 1, 2, 3, 4, 1, 2. There's B prime. And C, same way. 1, 2, 3, 4, 1, 2. There's C prime, and there's our triangle transformed. Translated by the vector v. Okay. You want to draw like a little... something like that. There you go. Okay. Easy peasy, right? Easy peasy. Go ahead, try letter B. Don't worry about filling in these blanks. I really don't like these blanks for the most part. Okay, so forget that, but just try letter B there. Okay, give it a shot. I'll do the same here. 30 more seconds here. 30 more seconds. I can't call anybody. Perfect. Okay, so there is where it is. Okay, there's where we translated A prime or ABCD to quadrilateral ABCD to quadrilateral A prime, B prime, C prime, D prime. Okay. Now, if you look here, right, our vector goes 3 to the left. And it's going to go up 1, 2, 3, 4, 5. Okay. And so, you can go up 5, left 3, up 5, left 3, up 5, left 3, up 5, left 3 to get to those points. Okay. Is it necessary to do it that way, though? Or is there other ways to do this? So again, what I did is I just went to each one of the points, A, B, C, and D, and I went up 5, left 3, up 5, left 3, up 5, left 3, up 5, left 3. Is it necessary to do it that way, though? All right. Avery, what do you want to say?
No, you can just do it from one of the points. Like, I did it from point D. I went up 5, left 3.
Okay.
And then
So once you had D prime, what'd you then do?
Then I counted the distance from D to C. It was you go 4 to the right.
Yeah, C is 4 to the right. So then from D prime,
Yeah, you go 4 to the right.
4 to the right, and that's where C prime has to be.
Yeah, and then you go left 1 and up 3 for D.
Right, and then to get to B, you're going to go left 1, up 3. So left 1, up 3, B prime, and then 2 over.
Yeah, what I did though is I went right 3, right
1, up 3.
Up 3 from D.
Perfect. Yes. Okay. So, and we're able to do that because translations do not change the size or the shape of the image. And so we can, once we get one single point, we can then use, the distances, the lengths, and the directions and stuff like that to get all the other stuff there. Okay, translations are the easiest ones to do that with because translations don't change the orientation, right? Reflections, rotations do change like the orientation of the point, so it can make it a little bit trickier there. But the translations, we can absolutely get away with that. Okay? We'll skip the reflect there. I think that one is pretty obvious. And I think we'll also skip the your turn there because I think we've got that pretty good. Okay, so what I do want to talk about, though, is drawing translations on the coordinate plane. Okay, so we can also name a vector. So we're on page 66 now. You can also name a vector using component form AB. Okay, so this is crucial here, all right? It looks like a coordinate. It is not a coordinate. First of all, it's not parentheses. It's like pointy kind of parentheses there. Okay, parentheses with like points on them. Okay, so this is again for the coordinate plane. So that, grouping symbol, the AB there, that's for a vector, okay? But it's just like what you would think. The A tells you how far left or right to go for your vector. The B tells you how far up or down to go. Okay, so if we read the rest of this thing here, okay, the component form for, if you look at that, that's not even the right, they don't have the right format there. It should be vector PQ like that with the little vector sign. Vector PQ is 5, 3, right? So if you look, to go from P to Q, you have to go right 5, up 3, and so that's its component form. Okay, we're going right 5, up 3. So that's another way to see it. Okay. So you can use the component form of the vector to draw coordinates for a new image on a coordinate plane. By using the vector to move a figure, you are moving the x-coordinate 5 units to the right. So the new x-coordinate will be 5 greater than the x-coordinate of the pre-image. And then using the vector, you can also move the y-coordinate up 3 units. So the new y-coordinate will be 3 greater than the y-coordinate of the pre-image. Okay? And we have this then for our I don't think this is like written right at all here. These should not be the pointy. They should all be parentheses here. Okay, so you want to change these to all be parentheses. This is a typo. It should be all parentheses. I'm pretty sure they meant this. Okay, this is another way to denote transformations is coordinate notation here. Coordinate notation. You see we take a point xy, and if we want to translate it a units to the right, we're going to add a to our x coordinate and keep y the same. If we want to translate something a units to the left, we take our original point xy, and we're going to subtract a from that x coordinate. For b units up, we're going to add b to the y coordinate, and for b units down, we're going to subtract b from the y coordinate. Okay? So this is another way to kind of show translations, taking a point and then, adding or subtracting to the x and y coordinates. That's how we can show a translation. Okay? So when you move an image to the right a units and up b units simultaneously, you would use the rule xy transforms to x plus a comma y plus b. Okay? Which is the same as moving the image along the vector a comma b, right? Because you can be right a up b. Okay? So that's all putting things together there. And again, this is called coordinate notation here. This notation is coordinate notation. Okay, when you take a point xy and then show the transformation. That's coordinate notation. Okay? So again, looking here, example 2, it says to calculate the vertices of the image of the figure, graph the pre-image, the original, and the image. So here are our pre-image coordinates. There's our vector 4, 6. So that means to every x coordinate in the pre-image, what are we going to do to it? If that's our vector, what are we going to do to each x coordinate here in the pre-image? Which number here is going to affect the x coordinates of these points? Which of these two numbers is going to affect the x coordinate? 4, right? Yeah, sorry. Anybody? 4, yeah. So then what should I do to each one of these x coordinates? Anybody? Write 4, which means we're going to do what mathematically? Add 4 to each one of these x coordinates. And then what about for our y coordinates? What does this vector tell us to do? Add 6. Exactly right. So if you look down here, there it is done for us. There are our pre-image coordinates listed. There's the image with the correct coordinate notation, x plus 4, y plus 6, and all the correct points with that. And then you can see it done right here. Okay. Alternatively, you can also just count, right, up, right 4, 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. There's b prime. Right 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. There's a prime and c prime. Same idea. Okay. All right. Let's move on here then to 67, and let's do this B where we have to fill in some blanks here, okay? Fill in some blanks. All right, so we've got, oops, sorry, let me unfreeze that. We've got our pre-image coordinates right here, listed for us in the table as well. And we have this vector, -2, 3. Okay, before we do this, let's go ahead and plot the pre-image here. So let's see here. So 3, 0. That's A. B is 2, -2. And C will be 4, -2. Okay. And then our vector here describes how we're translating things. So I'm off the screen again. I need to do a better job of keeping myself on the screen. There we go. Okay. So think about, before we do this, before we go ahead and do the transformation here, predict the image will be in quadrant blank. Quadrant blank. Okay, so think about that right now. Using this vector, translating this pre-image or original shape, what quadrant will we end up in when we translate using that vector there? So, Emma, what do you say? Which quadrant, sorry? The fourth quadrant. Okay, because what is the vector telling us to do?
It's telling us to move down and then right.
The first is the x component.
I'm sorry.
So now that we know that, where is it going to end up? So the negative 2 means we're going to go which direction?
Zero. Oh, never mind, it'll be the first one.
In the first quadrant. And why is that? Because we're going to go which direction here?
Left.
Left 2, up 3. Exactly right. Yeah, so we're going to end up in quadrant 1. Okay? So then to fill in our little blanks here, all right, Emmanuel, if we want to go left 2, that means I need to have x minus what here? Minus 2, right. And if I want to go up 3, it means I need to have y plus 3. You got it. Okay? And so we can then do the do the calculation for all these points. So 3 minus 2 is going to be 1. 0 plus 3 is 3. 2 minus 2 is 0. Negative 2 plus 3 is 1. 4 minus 2 is 2. Negative 2 plus 3 is 1. Okay? And so then I can plot those points. So 1, 3, 0, 1, 2, 1. And by the orientation, I can tell which point is which. So there is our transformed image. Did we need to use this table in order to do this translation? No. The directions didn't specify that we need to use it, but we did it just because it's there, okay? But we didn't need to use a table. What could we have done instead to translate from here to here? What could we have done instead? Jen? Yeah, just count, right? Left 2, up 3, left 2, up 3, left 2, up 3, right? 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. So it would work. All right. I'm going to have you guys skip this so I can give you more time to work on the homework, okay? So I'll leave those alone for right now. I'm going to give you more time to work in class. But I do want to talk about specifying the translation vector as well. So not only should we be able to do a translation given a vector, but we should be able to determine the vector given the translation. So in other words here, example 3 says to specify the component form of the vector that maps triangle ABC to triangle A prime, B prime, C prime. So you can see there's ABC, there's triangle A prime, B prime, C prime. They already drew in a vector there for us. Okay, so to get from B to B prime, you can see we have to go down 1, 2, 3, 4, and right 1, 2, 3, 4, 5. And so we end up with this as our component form. Right 5, down 4. Make sure you put the correct little pointy parentheses there when you name that vector. Okay, in the component form. If you turn the page, we got one more problem here to take a look at together. All right. So the component form for this vector, right? Well, between what 2 points do you want to use here? Let's start at maybe A. A needs to map to what other point? A prime. So the vector should be drawn from A to A prime. And so what will be the components? What's going to be the x component for that vector? What will be the x component for that vector? The first number here. Okay. 4. 1, 2, 3, 4. Give me the 5. Positive 5, 2 though, right? Because we're going to the right. And then what's the y component going to be? 3. And it's going to be a positive because we're going up 3. Okay. Let's just ask some of these questions here. We don't necessarily need to write them down. We can talk about them, right? Number 7, what is the component form of a vector that translates figures horizontally and only horizontally? What will we know about a vector, the component form of a vector that only translates figures horizontally? What would be true about that vector in general? What are we saying there? Luke, what do you say? It would be yeah, a blank, comma, 0, right? The y would be 0, so it would look something like this. Right. Because if we're only going horizontally, it means we're not going up or down, so the y component would be 0. Okay. Let's see here. Ooh, this is a good one. Let's skip down to number 10. Okay. A translation along the vector -2, 7 maps point P to point Q. The coordinates of point Q are 4, -1. So in other words, point P is the original here. Q is the image. Okay, P is the original, Q is the image. The coordinates of point Q are 4, -1. What are the coordinates of point P? So again, we are given the image's coordinates. How do we figure out the original or pre-image coordinates here? What could we do? What could we do?
Do the opposite, so instead of minus 2, add 2.
Right.
And minus
So we're going to take that 4, and instead of subtracting 2, we're going to add the 2. Instead of taking the -1 and adding 7, we're going to subtract 7. And this will effectively go backwards from what we did. Okay? We're going to go backwards from what we did, and so we'll get 6, -8 there. That's got to be point P. Okay? And if you then subtract 2 from the 6, you get to the 4. And if you add 7 to the -8, you get -1. So check it works. Okay? All right. Okay, I'll do this last one here. Number 11, a translation along the vector AB maps points in quadrant 1 to points in quadrant 3. What can we conclude about A and B? If we're taking points from quadrant 1 and moving them to quadrant 3, what can we conclude about A and B there? Go ahead, Emma. They both got to be negative. Why is that? What's your thinking there?
Just because, like, you have to move down and left
From quadrant 1 to quadrant 3.
Yeah, so they have to go 3.
Mhm. That's great. That's a great explanation there. Yes. If you're in quadrant 1 and you want to move to quadrant 3, which is down and to the left, that means A has to be negative to go left, and B has to be negative to go down. Right? So that would be it. Very good. Okay. Questions on any of that? All right. So let me give you your assignment. We're going to be starting it on page 69 there. All right. I'm not going to give you a ton of these, okay? So I'm going to just give you a smattering of them because some of these I think you kind of get the point and you don't need to do like a million of them. So, all right. So here's what I'd like you to do. So for your homework, starting again on page 69, okay? I'm going to give you numbers. Let's do like... Let's do 2 through 12 even. 15. Ooh. 16. I like that one as well. And 17. Okay. Ooh, sorry, one more, 18. There you go. Okay, that's it. I'll stop, I promise. No more, Mr. Witt, no more. So give those a shot. If you want to just circle them on your paper there, that's fine too. So go ahead and get started on that. You have the rest of class time to work on that. You might be able to even get it done in that amount of time. It's not that bad. Don't forget to also be working on that 10-mark stuff too.
like at homework.